Welcome to the DIY Honda Garage channel. Welcome to the diagnostic guide for the DTC P0746, which stands for CVT Drive Pulley Pressure Control Solenoid Valve Stuck Off in the Honda Civic model year range from 2016 to 2021. This trouble code indicates that the CVT Continuously Variable Transmission Drive Pulley Pressure Control Solenoid Valve is not functioning properly and has become stuck in the off position. The primary role of this solenoid valve is to regulate hydraulic pressure to the drive pulley, which is essential for the proper operation of the vehicle's transmission system. The solenoid is controlled by the Transmission Control Module, TCM, which sends a duty cycle output to modify the valve's position based on real-time driving conditions. When the valve is stuck off, it fails to supply the necessary hydraulic pressure, which can lead to transmission malfunctions. During conditions where the vehicle is stopped, with the forward clutch engaged and input torque exceeds specified limits, the TCM detects this fault and stores the code. Understanding this error is crucial for effective troubleshooting and ensuring the reliability of the transmission system. The DTC P0746 relates specifically to the CVT Drive Pulley Pressure Control Solenoid Valve, a component integral to the vehicle's transmission system. This solenoid valve is responsible for controlling hydraulic pressure to the drive pulley, which allows for smooth shifting within the CVT setup. The solenoid's operation is dictated by duty cycle signals from the Transmission Control Module, TCM, which adjusts the hydraulic pressure based on several factors such as engine speed, vehicle speed, and accelerator position. In the Honda Civic, the CVT Drive Pulley Pressure Control Solenoid Valve is housed within the transmission assembly, making accessibility a consideration during repairs. A malfunction in this component can hinder the entire operating efficiency of the transmission, leading to symptoms that may compromise overall vehicle safety. The TCM monitors the performance and condition of this valve to ensure that it operates within its specified parameters and will store the DTC when a fault is detected, indicating that the valve is stuck in the off position. There are several possible causes for the DTC P0746, each warranting attention during the troubleshooting process. The most immediate suspect is the CVT Drive Pulley Pressure Control Solenoid Valve, which may have become physically stuck in the off position due to internal failures. Electrical connection issues can also be a culprit. Loose or corroded connectors can disrupt communication between the solenoid and the TCM, leading to erratic or faulty performance. Additionally, an issue with the TCM itself could result in an improper output signal to the solenoid, causing it to remain in the off state. It's essential to explore each of these possibilities methodically. While the solenoid is a frequent failure point, ensuring that the electrical connections and the TCM are functioning correctly is equally vital for a complete diagnosis. Always carry out thorough inspections to confirm the specific cause of the DTC. When DTC P0746 is triggered, various symptoms may be present, indicating a malfunction in the transmission system. One of the most common symptoms is erratic or harsh shifting, which can be detrimental to the driving experience and even the vehicle's overall safety. Drivers may also notice that the malfunction indicator lamp, MIL, is illuminated, and the shift position indicator begins to blink, signaling issues with the transmission's functionality. Decreased acceleration performance is another significant indicator. Drivers might experience sluggish response times when attempting to accelerate, especially during rapid starts from a stop. Increased engine RPMs without corresponding speed increases can also accompany these symptoms. Identifying these signs early can prevent further damage to the vehicle's transmission and ensure a prompt and effective repair operation. In the first troubleshooting step for DTC P0746, The process begins by simply starting the engine of the vehicle. Once the engine is running, it's important for technicians to read the vehicle's speed to ensure it meets the parameters necessary for further diagnostic procedures. The vehicle must be in D drive position for this test. Therefore, confirming that the shift lever is set correctly is crucial. Monitoring and verifying driving conditions at this stage ensures that the TCM is able to gather accurate data about how the CVT drive pulley pressure control solenoid valve operates under load. This preliminary step sets the foundation for any further diagnostics, enabling technicians to understand whether the issues are rooted in the electrical system, the solenoid itself, or potentially the TCM. Continuing with the diagnostic process, the next step involves accelerating the vehicle in D position until it reaches a speed of 37 miles per hour, 60 kilometers per hour. This is a critical step because it provides the TCM with the opportunity to assess how the CVT drive pulley pressure control solenoid valve reacts during a typical driving scenario. Observing the behavior of the solenoid during this acceleration allows for any potential abnormalities related to hydraulic pressure regulation to be identified. It's essential that this acceleration is performed smoothly and consistently, as fluctuations in vehicle speed could yield misleading diagnostics. If the acceleration is completed without triggering any additional warning lights or symptoms, it indicates that part of the system may be functioning correctly, requiring further investigation into other components or connections mentioned in prior steps. The third troubleshooting step necessitates decelerating and coming to a complete stop after reaching 37 miles per hour. During this deceleration, the system is returning to an idle condition, allowing for the TCM to check whether the CVT drive pulley pressure control solenoid valve adequately adjusts hydraulic pressure to maintain the correct pulley ratio. This evaluation of system status during idle is critical, as any issues that arise during this phase could suggest that the solenoid valve is indeed failing to operate correctly. Properly functioning components will respond to changes in speed and load, maintaining stability within the hydraulic system. The TCM will monitor parameters such as the pulley ratio during these transitions to ensure expected behavior corresponds with actual system data, which is essential to proceeding with further diagnostics. At this point in the troubleshooting process for DTC P0746, the next step involves accelerating the vehicle with full throttle. This action is intended to place maximum load on the vehicle's drivetrain, allowing the TCM and the solenoid valve to demonstrate their functional limits. A healthy solenoid should appropriately manage the hydraulic pressure in response to increased input torque, thereby enabling the vehicle to accelerate robustly. Monitoring the immediate response during this full throttle acceleration is crucial. If the vehicle hesitates, stutters, or fails to accelerate as expected, there may be a definitive indication of a problem within the transmission system, particularly related to the CVT drive pulley pressure control solenoid valve. Each shortcoming observed during this test aids in defining the scope of the problem, leading to precise paths for further diagnostics or potential repairs. As we arrive at the final troubleshooting step, the next task is to once again slow down and come to a stop after full throttle acceleration. This final stop serves as an opportunity to finalize data collection, allowing any fluctuations or abnormalities during the previous steps to be captured accurately. Technicians must document observations carefully, particularly any peculiar behavior noted with the TCM's readings or any irregularities with vehicle performance. This documentation is vital, as it guides the decision-making process on whether further diagnostics target the solenoid valve, the electrical connections, or even the TCM itself. By aggregating all observations up to this point, technicians are better equipped to formulate a clear plan of action for repairs, ultimately striving to resolve the issues associated with DTC P0746. The final repair verification step for addressing DTC P0746 consists of a few critical actions aimed at ensuring the effectiveness of the repair. First, clearing the DTC using a scan tool is essential to reset the TCM and provide a clean slate for any new diagnostics. Once cleared, performing a test drive is necessary to evaluate the effectiveness of the repair and verify that the solenoid is functioning correctly. During this test drive, technicians must closely monitor the vehicle's performance, particularly the vehicle's acceleration, shifting behavior, and any warning lights that may illuminate during use. If the vehicle operates normally without triggering the DTC again, it's a strong indicator that the issue has been resolved successfully. One key takeaway is that maintaining records of the repairs and vehicle diagnostics forms an important part of effective troubleshooting and customer communication. Preventive maintenance plays a crucial role in prolonging the life of the CVT system and avoiding future issues such as DTC P0746. One key aspect is to ensure regular fluid changes, as using quality transmission fluid can help maintain efficient hydraulic operation within the control solenoid valve and prevent wear. Furthermore, routine inspections of the electrical connections involved in the solenoid valve and TCM can preempt issues arising from corrosion or loose connections, often leading to fault codes. Additionally, keeping the TCM software updated is essential in enhancing its performance, ensuring responsiveness to changing driving conditions, and optimizing the interaction with the CVT components. Implementing these preventive measures not only improves performance, but also contributes significantly to the overall reliability of the vehicle, resulting in fewer breakdowns and repairs over time. In conclusion, the DTC P0746 points to a critical issue with the CVT drive pulley pressure control solenoid valve stuck in the off position. Proper understanding and thorough diagnostics are mandatory to identify the root cause of the malfunction, whether it be the solenoid itself, electrical connections, or the TCM. Taking methodical troubleshooting steps from initial readings of vehicle speed to conducting a series of accelerations and decelerations provides valuable insights into the system's functionality. Moreover, preventive measures such as regular fluid changes, connection inspections, and TCM software updates are essential for maintaining the performance and reliability of the CVT setup. By following these guidelines, technicians can ensure that the vehicle operates smoothly and efficiently while minimizing future risks of DTC occurrences. Please like and subscribe to the channel. See you next time.